What about that percentage of precipitation?
Yeah, well, we abbreviate as POPs. So you see a forecast, you look at the forecast, 30% chance of rain, 70% chance of rain. What in the world does that mean, Tom? Because it means different on whether you're watching a broadcast station, if you're looking at the National Weather Service, or if you're looking at your app. It all plays a part.
Yeah. Probability of precipitation, or POPs, and then we use that with our forecasts, and depending on what you see here. I know that we quizzed one of our sales folks
We
earlier
did, yeah.
about today. What does this mean to you? But what does it mean to you? When you see 30% or 70%, does it mean it's going to rain 70% of the day? Does it mean it's going to rain for 70% of our viewing area? Could it rain 70% of our viewing area? Or 30%?
Or is it just the percentage that you will have rain at any point throughout the day?
Right.
So most of the day could be dry, but we are expecting a lot of storms. Later in the day, you might go with a 70% if you're the National Weather Service, or if you are looking at your app, because that's basically detecting your location on GPS and saying the probability that it's going to rain at any point throughout the day, even though most of the day will be dry, just because there is the likelihood it will rain at some point, your app might say 70%.
Yeah. So when you see that, should I cancel my plans for the day or not? What do you think?
Well, when we talk about it, it just is in terms of, again, a broadcast
Coverage.
station,
Yeah.
or if you're looking at your app, or if you're looking at the National Weather Service, because here in Little Rock, we cover a lot of counties, and you may not realize how many counties that THV 11 covers. 40 counties at least. We go all the way from South Central Arkansas all the way up to North Central Arkansas, as west as Polk County, and as far east. Once you bump up into Jackson, Woodruff, Monroe counties, then you get into the Memphis viewing area.
Well, let's take this last episode of rain that we had, because that was a widespread rain that pretty much lasted all day.
Yeah.
And it impacted all of the counties that we have here. Now, our percentage of rain was 80%.
It was 80%.
80%. I never ever want to go 100%. Because there's a burn factor there.
Absolutely.
I've done that before. It's a 100% chance. You think, okay, it's definitely going to happen, or it's definitely going to rain, it's definitely going to snow. But I've seen certain situations where it didn't in a particular area, and then what happens? The viewer gives you a call and says, I didn't get any here.
There's always that bus factor. Yeah. But with what happened last week, we had a solid area of rain, heavy rain, through the River Valley, through North Central Arkansas. 3, 4, 5 inches of rain fell. But that shield of rain took forever to get to there. Jefferson County, Lincoln County, Drew County did not see hardly any rain until the afternoon hours. So if I'm a viewer in Drew County or Jefferson County and you see 80% chance of rain, but yet most of the day is dry, you're probably thinking, what's the deal? What happened? And we try to stress that. We were like, most of the rain is going to be north and west of the metro. It may take some time to reach you folks in southeast Arkansas.
Sure.
So yes, we put a percentage on it, but you have to add more details. Now, if you were looking at an app, one of those junk apps, Apple or whatever is already installed on your phone, they might have gone with a 70, 80% chance of rain, just because they knew it was going to rain at some point throughout the day. But once again, a large part of the day was dry.
Right. Again, it doesn't mean it's going to rain all day at your locations. You take, let's say, the 20% likelihood. Take 10 counties in central Arkansas. And we try to do the best we can to break it down. And we've used these graphics before. Best chance, 80% southwest, 60, 50, depending on the speed of the system. You get 10 counties here in Arkansas, central Arkansas. You've got a 20% chance of a shower, an isolated storm in the afternoon. 2 out of 10 folks could get that shower.
Yeah.
But you really can't pinpoint who's going to get that isolated shower.
Yeah, absolutely.
Just know that it's there. So we try to incorporate words like isolated or spotty. And then when you get to those higher percentages, the scattered percentages. Last week, it was pretty widespread.
Yeah. You mentioned isolated. Even if it's isolated, we've seen it before.
We have.
Where nothing happens except right over Little Rock, the most densely populated part of the state, or where most of our viewers are, they get that 20%. They get that super soaking rain, and everybody else in the surrounding counties are like, what rain? But that 20% is like, it could ruin plans.
It could. It
Just
certainly
because it was just one lone shower, but
And I'll tell you whose plans could get ruined the most in the summertime. Those concrete pours.
oh yeah.
When you're building a house and you get a call from, I've got to pour concrete today. It's not going to rain. I said, well, there is an isolated chance, and it's at that house that's
Yeah.
trying to pour some concrete.
And we don't have the ability to say it's going to rain in this exact spot at this exact time. There's no way anybody can predict that. The only way we can predict something of that nature is if there's a boundary that we can see headed in our direction, or if there's a boundary already located there with daytime heating, then that's where the storms will likely develop.
Right. So, and that's a case this week where there's going to be a boundary that could settle into parts of Arkansas. So along that front, where you've got convergence, air masses coming together, you're probably going to see the best chance of rain in that area.
So let's take an example of what stray to isolated means. So this is what a future radar could look like for the entire state of Arkansas, and this is what radar is looking like during the afternoon hours. That is very much stray or isolated showers or storms, but you see what's happening. It could be one right over Pulaski County. Nothing's happening in Garland County, Perry County, or Faulkner County. And then when we take a look at something maybe a little more spotty in coverage, especially into the Ouachita's here, there's a little more grouping of spotty showers and thunderstorms developing. And then the coverage continues to grow.
Right.
Scattered, you get the idea, widespread, numerous. There's numerous where
Largest
a large
swath of
part
Arkansas, yeah.
of Arkansas, just because it's going to be a huge shield of rain moving through, and then widespread is everybody gets rain across the region. So here's the breakdown of, I think, how we can look at things in terms of coverage and then also how it may impact your plans. When we take a look at 10 to 20%, that's going to be stray or isolated coverage when you look at the radar. Plans, most of the day and most of the area, the viewing area, will be dry. Not to say there won't be a downpour that happens just over your house,
Right.
but 5 miles down the road, it's dry, or 5 miles in the other direction, it's dry. Then we look at coverage spotty to scattered, a 30 to 40%. Parts of the area will be dry or could be wet. And we use the 30 to 40% really in terms of summertime stuff, because you have the daytime heating, most of the day is dry, you're good through the morning. But then you get into the mid to late afternoon hours, those storms start to pop up. And they could grow in one storm and then expand into other storms. We've seen that happen several times. Also, maybe most of the day is dry and you have a front moving in, producing a line of storms or a squall line that will impact the area later in the day. We'll go with a 30 to 40% chance of rain here on THV 11 on the forecast. Apps may go higher. When you take a look at 50 to 6% chance of rain, that's numerous to widespread coverage. So more of the area and more of the day will be wet. 50 to 6% chance means there's probably going to be a few hours of wet weather for the most part. And then 70 to 80% widespread coverage of rain. Most of the day will be wet. Could there be some dry time? Absolutely. But 100% chance of rain, that's when you have like a tropical system that's just going to pour all day long. It's going to be a washout. That's the only time we use 100% chance of rain. And that means 100% chance the day is going to be wet, and then the entire area will be wet as well.
I still won't say 100%.
99.9%, right?
I'll go as high as 90% chance of rain. So hopefully this helps, that it's based on coverage.
It is.
Not necessarily that it's going to rain X% of the day. Although when you get into those higher percentages and coverages, it could.
Yeah. It's coverage of the actual landscape, but it's also coverage of what period of time frame of the day it will be impacted. So hopefully that answers some questions. Hopefully it doesn't stir up any more questions you may have about this. Some people probably like, okay, can we go over that again? But yeah, it all depends on what you're looking at. The app, the National Weather Service forecast, website, or broadcast, it's all going to be different. So.
Yeah, and of course, we'll provide you with a little guidance on whether or not we think this has the potential to be a wide-ranging type of situation, precipitation of rain, snow, or whatever. Or, like you say, the summertime. Hey, can't rule out an isolated shower storm.
Yep.
Or spotty shower storm.
Yep.
Okay.
Arkansas weather always changes.
Yeah.
And you never count anything out. Like we've seen many times where, oh, it's a 10% chance, and then you have one storm, and then it just develops into this cluster of storms, and you're like, uh-oh, I should have been at 50%, not 10%.
Then you have some explaining to do. It happens.
Yeah.
Right.
Let's talk about Doppler radar, because you always see it. We always say Doppler radar shows this, Doppler radar shows that. So what is Doppler radar in the first place? Well, it is an instrument that all meteorologists use, and it basically is an instrument that sends out a pulse of energy. Radar stands for radar detection and ranging, and this pulse of energy goes away from the radar dome. For instance, this one's located into North Little Rock, and then it will make its way well away from the radar. And as the curvature of the Earth is an influence, that radar beam will tilt up. So it gets higher and higher above the surface the farther away that it is from the radar dome. This beam of energy will hit a raindrop, a snowflake, hailstone, and then that beam of energy will be backscattered, and some of that energy will come back to the receiver in the radar dome. How the information is interpreted is basically the more energy that the receiver gets from whatever is out there in the atmosphere, it will interpret it in different colors. And this is known as DBZs when we take a look at your actual weather radar. You're seeing two pulses of energy though, and that's because radar has changed really since the past 10 years. In 2013, we just had a horizontal pulse of energy that would make its way towards a storm, and that just told us limited amounts of information. But since 2013, the radars send out a horizontal and vertical pulse. This is known as dual pole Doppler radar, and this tells us valuable information, especially when it comes to a severe thunderstorm or a tornadic storm, because now we can use that information to detect what type of shapes are into the atmosphere. Are they similar or are they different? And usually when you have just a shield of rain in a thunderstorm, it will turn out to be one color. And that is known as a high correlation coefficient. However, when you have a tornado, that tornado is picking up debris. It can be pieces of homes, trees, cars, whatever, and that debris can be interpreted as different shapes are happening within this sample that the radar beam is getting, and that will tell us, okay, we have a confirmed tornado on the ground. And we can actually tell you how strong that tornado is according to how far this lowering of the correlation coefficient can be spotted going from the cloud level higher and higher and higher. Of course, the stronger the tornado is, the higher that debris will go. 25, 30,000 feet, it could be, pieces of paper, but that pieces of paper mixed in with rain and hailstones will be interpreted as different types of shapes according to the radar. Radar works because of the Doppler shift. And the Doppler shift example is going to be, think about what happens when you have a train or an ambulance and that's coming towards you. You can hear that sound, and it gets higher and higher and higher the closer that it gets. And then as that train or ambulance passes you, then that sound gets lower and lower and lower. The frequency changes according to your perspective. And we use that for Doppler radar to determine, okay, are these raindrops, hailstones going away from the radar, or are they going towards the radar? And that makes it very important in defining rotation within a storm. So when we take a look at a radar sample, this is what you typically have. Lots of colors, and these colors tell us what's going on in the atmosphere. This is the reflectivity part of the radar. So this tells us what objects are happening into the atmosphere. And most likely, it's rain. When you have reds and oranges, that's typically heavy rain. And then you get into the lighter colors, the greens and the blues, then your intensity of the rain will be dropping. We can also detect hail with radar, and that's when you see colors more the purples and also the blacks. We also have other algorithms that can be used by dual pole Doppler radar to tell us more information on hail size. A situation that we always have going on here is supercell thunderstorms. And when you look at this, we have that classic hook echo. So we have the heavy rain, probably some hail. This is from the Hot Springs tornado back in 2024. And then also we have the velocity data. And this uses that Doppler shift I was talking to you about, the velocity. So when we take a look at this, we're watching for the different colors, because at the top of the screen you see toward and away. And that's the radar detecting the motion of what's going on in the atmosphere, if it's towards the radar or away from the radar. The radar is located in North Little Rock. So we're in Garland County, and the red is going away from the radar, the blue is going towards the radar, and these colors are picking up. So we have a green splotch there, pixel, and that's showing 80-mile-per-hour winds going towards the radar, and then the red is about 40 miles per hour going away from the radar. So when you add that together, that's almost 120 knots, or 120 miles per hour of shear. And that would give us an idea of how strong the tornado could be in that location. When you have a severe thunderstorm, another solution using radar is to basically just stop the scan and just focus on the storm, because usually the radar beam is just going around 360 degrees, and it's going low level and then mid level and then upper level, and just does these tilts over a period of time, which takes about 3 or 5 minutes. But when you have something known as supplemental adaptive intra-volume low-level scan, or more simply SAILS, that the National Weather Service can really focus in on one storm, because when you have these weak, short-lived tornadoes, if you don't have SAILS, you're not using that opportunity on radar, you may miss a tornado. It's happened before. I'm sure it's going to happen again, because sometimes tornadoes spin up so quickly, minute, 2 minutes, and by the time the radar scan gets back, it's gone. So it can actually happen in between the scans of the radar. I've seen it happen before, and I'm sure it's going to happen again. Radar coverage is very important, and here's a map of all the radars across the country. We notice some big lack of coverage or holes in the radar. Wyoming, Montana, there's not a lot of people out there. They don't see a lot of severe weather, so radar's not necessarily needed. But here in Arkansas, we do have a lack of radar coverage. Northeast Arkansas and also Southeast Arkansas. And here's an example. Because with the curvature of the Earth, the radar beam tilts up. And that radar beam, once it reaches like Sharp County and maybe the community of Ashflat, the beam from North Little Rock could be 10,000 feet above the surface. Yeah, we have other radars around the region, Springfield, but that one's 12,000 feet above the surface. Memphis, 11,000 feet above the surface. So if there was a tornado, and we've seen it happen, this just happened recently with Cave City back on March 14th, the radar data is not as good. It's not as clear, and we're not getting a good sample of what's happening closer to the ground. It could miss the tornado. We may not know a tornado is actually on the ground until it lofts debris. And I think that was the case really in Cave City, because yes, we saw rotation into, 10,000, 11,000 feet, but it was hard to depict because that's also where the low-level jet was. So it makes it much more difficult to really pick out low-level rotation when your radar beam is that high. So hopefully, maybe in the future, there will be more radars to cover up all these holes. That's just a wait-and-see situation. There are some companies that are trying to help with that situation. but haven't heard anything recently on exactly who is getting the data from those certain companies. We'll certainly keep you updated. Let's say you were having a nice summer picnic out by the lake and you saw this cloud headed in your direction. It's time to batten down the hatches. Now, this one may not produce a tornado, but it will produce the potential of some gusty winds, and rain is surely to follow behind this. This is known as a shelf cloud. It looks like a tsunami pretty much happening in the sky, or a tidal wave. But there is a simple explanation for this ominous view. And it's all because, remember when I talked about the downdraft, that cooler rush of air, well, that cold air is heavier. Cold air is heavier than warm air. So as the colder air rushes away from the storm, it pushes up that warm and humid air. With that warm and humid air rising above this cold air, it cools, condenses, and forms this overhang cloud. It's a shelf cloud. You see that? It's heading your direction. Get ready. You're most likely going to have some gusty winds and also some heavy rain. Now, this type of cloud, that's what you really want to watch out for. This is out into the Great Plains, the structure of the thunderstorm here, and what you notice is here's the base of the storm, but here is the low-hanging wall cloud. And if this wall cloud is rotating, that means a tornado could be happening any moment. Also, tail cloud, or this is also known as the beaver's tail. This tells us there's a lot of warm air being drawn up into this supercell thunderstorm, and that can also be a precursor to the potential of a tornado. The forward flank downdraft is well off to the right part of the screen, and then you have this horseshoe area, and that's what develops the hook echo signature on radar. When we break it down even more, looking at the horseshoe area, this is going to be your rear flank downdraft. So this is where there's going to be some really gusty winds happening, but where the tornado is located, it's going to be on the northern side of this horseshoe. And you point out here with the heavy rain, this is going to be the hail. This is where visibility is really obscured. But then the tornado, you can't spot it because it's likely behind the rain. Here's another example for you. This is for another area of Scud. Looks like a tornado. It's not a tornado, certainly very ominous. I mean, you see that there, and it looks like there's a funnel on the ground. This is a scary situation for a lot of people, and actually something like this would get mistaken for a funnel cloud or a tornado. But you notice the ragged nature of this. And then also, if this was a film, it wouldn't be rotating. It'd be broken up in fragments, and you would certainly see the lifting of the air. And this does show there's a lot of lifting happening within the storm, but you can see this type of situation even with a general thunderstorm when you look off before the actual storm arrives. So if you see something like that, certainly watch out for it. But anytime you see rotation in the clouds, that's a clear sign that you want to get to your tornado safe place. Severe weather season continues here in Arkansas through April, May, and then eventually ends in June. So hopefully things will quiet down because we've already had a nasty round of tornadoes in northeast Arkansas, and we don't need any more. For Weatherwise, I'm meteorologist Nathan Scott. Thanks for tuning in. If you have any pictures, videos, or questions about severe weather, please send them in my direction. You can email me at nscott@thv11.com, or you can reach out to me on my Facebook page. Just put in the search engine, Nathan Scott THV11. Thanks for watching and have a great day. I'll see you soon.